Okay, we're going to solve the system using Gaussian elimination. X minus 2y plus z equals 3. 2x plus y minus 3z equals negative 4. 3x plus 4y minus 4z equals negative 5. First step is to write down the augmented matrix. So that will have the entries 1, negative 2, 1, and 3. 2, 1, negative 3, negative 4. 3, 4, negative 4, and negative 5. This guy, this row, is our current row 1, second row, current row 2, so R2, then R3 is the current row 3. Okay, so the process for Gaussian elimination is this. You work column by column, you get your pivot. So for instance, in the first column, that guy is going to be our pivot. Doesn't have to be a 1, but it is in this case. We're going to use the pivot and row operations to get zeros below the 1. And then we'll be finished with that column, and we'll move on and do the same thing with the pivot in the second column, third column, and then it'll be in row echelon form. Here we go. So what I'm going to do is I'm going to take, to eliminate this 2, to make it a 0, I'm going to take, that's going to be a new row 2, so I'm going to take the current row 2, subtract off 2 times the current row 1, and then that will be my new row 2. So that's how I notate that. And then I'm going to do something similar for row 3. I'm going to make it so that this 3, there's a 0 where this 3 is. So that's our row 3. We're going to take, we're going to use our pivot row to do that. So we're going to take minus 3 times the row 1, and that's going to be our new row 3. Save space. I'll make that a little smaller. And I'll do some scratch work. Negative 2 times row 1 would be negative 2, 4, negative 2, negative 6. And then row 2 is 2, 1, negative 3, negative 4. Add them up. 0, 5, negative 5, negative 10. That's our new row 2. And then I'm going to take negative 3 times row 1, so negative 3, 6, negative 3, negative 9. Add it to row 3, 3, 4, negative 4, negative 5. We get 0, 10, negative 7, negative 14. That's my new row 3. So the column is finished. The rule in this class is every time you finish a column, you rewrite the matrix. Row 1 hasn't changed. Row 2 is 0, 5, negative 5, and negative 10. And then that's my new row 2. And then row 3 is 0, 10, negative 7, negative 14. And so now I rename my row 2, my row 3 become what I just inserted. I move on to the next column. And I notice that this guy here is my pivot, because the pivots always follow that stair-step pattern. Okay, so I'm going to use that pivot to get a 0 below it. Okay, that's going to be a new row 3. So write down the row you're changing, and then what are you doing to that? Oh, you're going to use, the pivot row is now row 2, and so you're going to take, let's see, you're going to multiply row 2 by a negative 2, and then add it to row 3. Or equivalently, go minus 2 times row 2. Row 3 minus 2 times row 2, and then that becomes our new row 3. A little bit of scratch work over here. If I do that multiplication to row 2, if I multiply by negative 2, I get 0, negative 10, 10, negative 20, and then add it to row 3, 0, 10, -7, -14. I do that, I get 0, 0, 3, and then, oops, that should have been a positive 20. And then that would be just positive 6 there. Okay, so that now becomes my new row 3. Row 1 and 2 have not changed. 1, -2, 1, 3. 0, 5, -5, -10, and then 0, 0, 3, and 6. This is now in row echelon form. And what we can do at this point is convert it back to the related system of equations, and that new system of equations will have the same solutions as the original system. So the corresponding system, if we use x, y, and z for our variables, would be x minus 2y plus z equals 3, 5y minus 5z equals -10, and 3z equals 6. So we use what I call bottom-up substitution or back substitution and solve the last equation first because it's super easy. Look, you get z equals 2 when you divide both sides by 3. And then you would plug that z equals 2 right there and get 5y minus 10, minus 5 times 2, minus 10 is equal to -10. You add 10 to both sides, you get 5y is equal to 0, so y equals 0. And then you plug the 2 in here and the 0 in here, and you get x minus 0 plus 2 is equal to 3, which means if you subtract 2 from both sides, you get x equals 1. So your solution can be written as an order triple. In vector form, it would be 1, 0, and z equals 2.